problem 9 says the position of a particle moving along a line is given by s of t equaling 2t cubed minus 24t squared plus 90t plus 7 for t greater than or equal to 0. For what values of t is the speed of the particle increasing? There's so many different ways to do this problem. If you, after seeing my solution, if you'd like another, talk to probably anybody in physics, and then you should be able to cross-reference what they say with my explanation. But I'm just going to stick to some very core principles here. So here we go. So first thing, I'm going to go ahead and make note that the given function is a position function. And then if I take its derivative, I would not have exactly a speed function, but I would have a velocity function. And think about for a second, what's the difference between speed and velocity? And not a whole lot. But s prime of t would be 6t squared minus 48t plus 90. And then from there, if I'm looking for, see, you could kind of take a couple different routes. So one thing you could do is you could just make a note that speed is the magnitude of velocity, whoopsie, or the absolute value of velocity. So basically, velocity, because it gives a direction component, can be positive or negative, but speed should always be positive. So what I'm going to do to answer this question is really what I want to do is get a graph of the speed function. And I'm going to start by getting a graph of the velocity function. So to graph the velocity function, I personally would complete the square by grouping the t values and factoring out the leading coefficient. Dividing my linear coefficient by 2, squaring the result. And then I just added 6 times 16, which is 96, so I would need to subtract 96. Knock off. Okay, so now what do I have? I have 6 times t minus 4 squared minus 6. So if I was to graph velocity, I could do it pretty quickly. So let's see, they said just for t greater than or equal to 0, so. Okay, so where's the vertex of this velocity function? It would be at 4, negative 6. Okay, and then it's got a vertical stretch by a factor of 6. So I'd go from the vertex, I'd go out 1 in each direction and then up 6, which has me hitting the t-axis. And then, okay, now keep in mind, this is not the graph of the speed function. This is the graph of the velocity function. But it's this nice little parabola here. Okay, so now with purple pen, I'm going to come in and graph the speed function. So velocity is in pink, and now let's graph the speed function. Well, speed is the absolute value of velocity. So where velocity is positive, speed will be exactly the same. So here in purple, I'm showing that speed and velocity agree as long as velocity is positive. When velocity is negative down here, where it's underneath the t-axis, the speed would just be its positive equivalent. So this point right here at 4, negative 6 would be at 4, positive 6. And then instead of going underneath, it would just be a perfect reflection, because speed would just be that exact thing, but positive. So this purple graph is the graph of speed. The speed function for that particle. So now you can look at your own picture and just kind of read it right off. So they wanted to know for what values of t is the speed of the particle increasing? Well, it looks to me like the speed of the particle is increasing from 3 to 4 on this interval, and then it's increasing from 5 to infinity. So the answer would be the speed of the particle is increasing all t from the intervals 3 to 4, and then from 5 to infinity. All right, which I believe matches up with option E. All right, my friends, I hope this helps. Take care, everybody.